Hi guys.
Okay, what are we going to talk about?
Yeah, we're going to talk about like FHIR validation. Whoever tried to implement FHIR validation? Okay, who enjoyed this process? Okay.
Well, hold on. who is actually implemented a FHIR validator? Yeah, I know. Yeah. That's the,
Yeah. Who think it could be better? It should be better. Okay, so that's what we're going to talk about.
Dude, you got a lot of things open. Show me that presentation again.
So how this came about is that
There it is.
a few years ago, for the .NET stack, we were working on a new validator that was easier to debug. Right? Our validator was more or less, I'll suck in the structure definition, you give me an instance, and I'll validate it. And then if it didn't work, we had to figure out how it had interpreted all the slicing and all that stuff, and the snapshot, and it was pretty hard to debug. So we were thinking about what if, also for speeding it up, what if we take the structure definition, pre-process it into something that is optimized for validation, that actually has a class structure that represents what we are validating in a more operational way for us, instead of a more declarative way, if you can say it like this, in structure definition, and then stick to that representation. And so we run that. So and so we kind of found we kind of made some intermediate format, if you want, for validation, specific for validation. Now, I do meet this guy now and then on these meetings, and so he said, yeah, I'm working on the same thing, basically. And so we decided to, this was at DevDays last year, I think, more formally, sit together, with 1/10 of this group, I guess, and discuss something that you wanted to call FHIR Schema, right? Hey, the slides are up.
Yeah, I can like some problem statement, yeah. So we all understand that FHIR validation and profiling is very important for FHIR ecosystem, yeah. But there are some problem, yeah. So we really have 1.5 official validators, yeah? Java and C# and maybe some. So we have some like FHIR servers, closed validators. Nobody knows the quality of that validators because we don't have a good test suite for that.
That's another problem.
Yeah, when you start talking about how to implement validation, you know that there are 2.5 people who understand all the details, because you always hear it is something mysterious, hidden knowledge. Only Graham understands how the snapshots are generated.
I mean, if we're mentioning someone who knows all the details, like, what's this additional binding thing? Do I have to do that, implement it too? Oh, crap.
Yeah, there are always some corner cases out of the pocket.
Absolutely.
So you never pass. Yeah, so... Yeah, and if we look at the facts, so for example, there is no good JavaScript validator. Yeah, that's it. Why? So what's wrong? There is no Python validator. There is no Go validator.
Because it's hard to implement a validator.
Yeah, there's some subset of validators implemented in the different systems, but yeah. So why that happens? And for me, I can compare my journey with the JSON schema. I did implementation of JSON schema in Clojure in a couple of months with a lot of optimization. It was easy journey. So I come to JSON schema. They do have a test suite. They have a specification which describe almost like algorithm how to implement it. So you just sit down and implement it, use tests, and it works. So
maybe for the oldies here, this reminds me of the mess that was XSD schema, right? There were also multiple validators that did different things. So maybe they learned from that.
Yeah, and that's how it should work, yeah? If you look at the FHIR, it should work in terms of validation like JSON schema, yeah? We do have JSON schema validators for each technology, like multiple versions.
Are they like, do you know whether they are kind of comparable? Do they do the same things, or is there like?
Yeah, they usually do, and they're the official test suite, quite comprehensive, so if you pass it, so you're good, yeah. So, and completely different experience about the FHIR validator, yeah? So we're doing it for many, many years, and we're still not satisfied. So we still think that it should be better. It could be better. So yeah, and then this crazy idea come to our mind that maybe we can take like the meta framework of JSON schema and apply it to FHIR.
Right.
Yeah, and for me, I think, yeah.
Well, that last bullet.
Yeah.
On the previous slide, JSON schema is richer than FHIR validation. Are you sure?
Yeah, yeah, I'm pretty sure. So the JSON schema has much more rules. So if you compare, it's like 2 or 3 times bigger than FHIR.
I thought we did a good job with all this slicing stuff and
Yeah, the slicing is just one type of rule. Yeah, but in JSON schema you have a dozen of rules, like one of, any
you don't know how many extensions to structure definition Lloyd has made up by now for validation, right? Okay, but it could be. Okay, yeah. But it's easy to miss. That's the whole point. If you read through structure definition, you really don't understand how complex validation is, right?
Yeah. Yeah, and the question is why? Yeah. So what's wrong? And I think the quite simple answer. So the structure definition was designed for authoring. It wasn't designed for implementation. So because it was designed for modeling, yeah? So
50% of the people who were guilty for the sign of structure definition are standing next to you.
Yeah, I understand, but you can tell the story.
Yeah, that's right.
I think because you try to solve like the theoretical problem, yes, so how resources can be profiled, how they should be profiled. You never think how it can be implemented. So
no, that's true. That's true.
Yeah,
it was a structure definition.
Yeah.
Right, that's true. Yeah.
So implementation come like as a second step.
Yeah.
So and can we try like and design it for implementation?
Right.
Yeah.
Yeah. I got to admit, and that's not blaming another standard, but we took a lot actually from ADL in OpenEHR, right? Especially also the snapshotting and the slicing and so on. That was, Thomas Beale warned us. He said snapshotting is a hard thing, and we were like, nah, we don't hear it. But yeah, that's true.
Yeah, and another point that I think the answer is very simple. So the data shape should be the same as the profile shape, as a schema shape. So then things becoming much more easier. So I do have a quote by Rob Pike, yeah. So the data structure matter, not algorithm, because if you pick the right data structure, the algorithm becoming much straightforward. And I think that's the problem with the FHIR structure definition. It is not suited for implementation. So if we can design the data structure which close to the algorithm for running validation, which is exactly like what JSON schema provides, like the same shape of schema, the same shape of data. So you you are understanding how it should work. So you walking data, you walking schema. So you're running your rules and you're collecting errors.
Well, one of the things with structure definition, of course, is that it's flat.
Yeah.
And that's because in V3, that was before my time, but Lloyd's sitting here. In V3, we had this MIF format. I think that was hierarchical, and that didn't prove to be. I mean, there was a reason we made structure definition flat again. That didn't prove to be really successful either. But I agree. The first thing we do in our validation schema is restoring the hierarchical structure and looking at and actually unfolding the discriminators, for example, in slices, because it's really hard to understand the discriminator that moves into like structure definition somewhere to point to an element definition that specifies a constraint. Those are really hard things to figure out when you write a validator.
Yeah. So and the solution could be like that. Your schema should follow the shape of the data. If it is, so you just recursively walk the schema, you recursively walk the data, and you execute the rules, and you collect errors. Yeah. So that's the core idea behind the FHIR schema.
Yeah, we were both the .NET side and you, we were both inspired by JSON schema. Right, that's true.
Another question is a snapshot. For me, it's a snapshot. It's a like personal opinion. So it's implementation detail. Yeah. So snapshot pollutes all the distribution. It increases the size. It's a part of validation algorithm, which is just split into the parts. So for me, it's implementation detail. And so what we did, so we implemented snapshot-less validation, and I think passed all the tests. So you can use snapshot to speed it up, but you don't have to.
This is still a part where I am really curious about your implementation, because the whole idea of snapshot was that you got everything in one file, more or less. If you want to do rendering or validation, you don't need to go resolve into packages or all that. But by now I realize that's not completely true. But the original idea was a snapshot would give the client that receives the snapshot the idea that he doesn't need to go out, like a compilation phase. You don't need to go out and fetch other stuff.
Yeah, but that's implementation detail, yes? That's deduced logic.
Yeah, but you know, saying this is an implementation detail is what killed V3, right? That's an implementation detail, right? So I don't know about that. It was meant to make stuff easier for clients, and I don't know if that worked because stuff gets really big. Yeah? But when I tried the initial versions of our validator to just what you did, not use the snapshot but the differential, I found that I was basically doing at least some snapshot generation in the validator to achieve the same thing. So I'm still very curious to see how you fix that. But I admit it's an attractive idea to just have the differential because they're lighter weight, they're easier to read, and so on and so on.
And this is a source of truth, yes, and you don't repeat yourself,
source of,
and you
well,
don't
yes.
depend on some extra component which is like snapshot generator, yes. And but finally, if you pick the right data structure, the snapshot becoming just a merge. So this is so how we can check that we got to the right data structure. If the snapshot becoming just a simple, straightforward merge, so then we pick the right data structure for schema.
So what I found hard, but I guess you have a solution for that, is that if I do validation based on the differential, right? I'd have say the most derived profile point to the base and so on and so on. You move down the chain, you start validating up from there, I guess. But you have to avoid that you don't validate the same things twice. So if the base has put a constraint on a value set that's been then constrained in a sub profile, you have to make sure you don't do the first one that had been constrained by the profile, right? And that I never got that logic to work. So how did you do that?
Yeah, so the picture, so the idea that when you're walking the data, you have a context, and you have multiple schemas in a context. We even run it with 100 of profiles at the same context. So and this is I think quite realistic scenario when you want to run one resource against 100 of schemas, 100 of profiles. And then you just, when you're walking the data, you're walking the multiple schemas. Yes, you may have duplicating rules, but you can easily just memorize these rules, and if it's already run, let's say some FHIR pass expression, if it's already run, you just don't run it again. So, and another interesting part, if you do this snapshot-less generation, so that you know which profile produce the error, because you're running these rules from specific schema, and that's, I think, the problem with the error reporting for the snapshot, because you should put additional information into snapshot to understand that this rule comes from base profile.
Okay.
Yeah? Or you're just saying something is wrong.
I guess that's true. Yeah. It's
And
hard
if
to
you're
report.
trying to run against 5 profiles, then you still have the same problem, yeah? Because they have the same basis, so you're gonna...
But basically, you have found out how to avoid me running first validation, say expensive terminology validation on an element that turned out to be constrained by another, by a sub-profile, that you don't do these things twice. That's something you succeeded in fixing by making a unique ID for these things.
Yeah, there's some.
Well, you told me you're going to write.
You're
going to write a JavaScript demo validator, so I'll check that out. Anyone here experienced with this discussion of using snapshots versus differentials and fetching these things? Have any of you been working with that? Any IDs? I mean, I have to admit they're huge, but we're all, at least at the .NET stuff, is all still based fully on the snapshot. It's easier.
Give him microphone.
Okay, we're gonna. Yeah. There you go.
Go first. I mean, it absolutely is easier, but it falls somewhere in the middle, right? It's not enough to do validation because there's pieces missing, and it goes out of date really easily. So it's great to say, for this package that I've done, for this IG that I've put together, I've got all that kind of stuff. But when you're really working with it and especially when you're trying to do things at scale, it falls out of usage pretty quickly. I can see where Gino likes it for code validation.
Yeah, but I'm also going to do a counterpoint because we had an argument about this on Zulip. When you do things like base national profiles, you want to pin it to whatever snapshot you generated today when you published. Because if you change the validation rules a year from now, you figure out even that your rules were wrong before when you generated the snapshot, you can't reconcile that. So you need to use the snapshot because that's the one that's approved and regulated and all that other stuff.
If all of the dependencies were also versioned as part of that.
Well,
then
Yeah, well, and that's the point. If you have a different resolution downstream, if you have a different resolution downstream because the versions weren't pinned, now you're in a whole heap of trouble because now your regulated base profile will validate differently depending on who's validating it.
right. I'm a little reluctant to trust the snapshot when I don't know all of the pieces that went into
Yeah,
it.
the counterexample is like, let's say you have a technical release, yeah? So you're going to fix some mistake, which you published in the core. And you have 1,000 of profiles which inherited from it. So then you should rebuild the whole simplifier, yeah? Yeah, why?
Because it's not... I can be loud. I don't think people online will hear me. So no matter how loud I yell, you won't hear me online. But yes, you have to. Because when you have something like a base profile, the regulatory requirements, you can't just pull the rug out of all of your implementers. You can't say, well, we issued a new technical correction to the FHIR core spec, and because of that, your certification's no longer valid because we've changed the validation rules on, this program that you're certified through. We can't change those rules.
That's a node packaging problem, though, not a snapshot problem.
It's both.
Yeah, it took me a while, and last week I'd been working with Gino on versioning, actually in Dallas at the work group meeting, we discussed how to deal with the diamond problem in packages, in NPM packages, but also there starts to be package authors, and Lloyd here is one of them, that actually using a feature from NPM that's called aliasing, so you can include two versions of the same package from the same package, right? And the question that pops up with the diamond problem already is, so if you have a snapshot if you're referring to a profile that has a snapshot and that has been snapshotted by an older version, right? You kind of fix the diamond problem in the sense that you have that older version in your snapshot there, and you're using that. Well, stuff that is like more on the top using the newer versions have the newer snapshot. So it somewhat fixes this diamond problem, but when I start to think about how if you then create snapshots based on these two things, how you're going to merge the two different versions into one, it starts to hurt, right? But it's definitely true that at least for this diamond problem, if you have the snapshotted version, some of your versioning pains are resolved because the stuff's in there. And if you do everything in differentials, you'll have to do that really smartly to make that work the same way. Oh, hold on.
I had a lot of, oh, thank you.
We have three mics. Okay, great.
So we just had a discussion about it, Nikolai and me. So in my experience, I have trouble trusting snapshots that I did not generate. And about the fact that a publication that has a snapshot, is really that snapshot the publication? Because the publication is actually the differential. what you need is
source
to
of truth, as you said. Right.
You need to be strict about the dependencies and the versions of the dependencies. But in the end, the publication, if there is a conflict in the publication between the snapshot and the differential, who's the correct one? And in my experience, even from the base profiles in FHIR, the correct one is the differential. And the snapshot might have errors in there. And
yes,
it happened
I know.
in the vital signs profiles.
And the .NET and the Java snapshot generator will generate different snapshots also, and then probably other stacks will generate them. So I have to admit that our simplifier team basically ditches all the snapshots because it doesn't trust the snapshots. And so with this diamond problem, it just selects the newest version, which is not what we discussed in Dallas 2 weeks ago, but it is, I agree with what you're saying. So there are teams within FHIR too that say we don't trust the snapshots, we ditch them all and we recalculate. So that makes this versioning thing even a bit harder. Okay, so it sounds like differentials, maybe they are the way to go. Okay, next. Schema itself, I guess, or we're dying to see some schema now.
Yeah, so, yeah, we discussed it this year ago, these ideas, so, and we just go and try to implement it. Initially, like internally, to check it really works, because we were scared that there's a lot of corner cases you never will be able to pass. Yeah, so, and yeah, I think we succeed.
And honestly, I was like, okay, I'll let Nikolai do the dirty work and see if there's any corner cases we missed. Yeah.
Yeah, so, and we got this FHIR schema draft, so which we would love to share. I hope it will become the community project. So not the core, but yeah, just a community project, and proof that it will work. So the general idea, apply JSON schema ideas to FHIR. Yeah, so the like strict algorithm spec and the reference implementation in JavaScript, so people can look at this and implement it. As well, like other good test suite for that, so which we all need. Yeah, so.
Yeah, because the only tests we currently have, if you're doing something like validating your validator, is HL7, and specifically Graham, I think, has published a whole bunch of validation inputs. So structure definition plus instances, and then the operation outcomes that his Java validator produces. And we're using the same files and putting our .NET outcomes in the same thing. And so you can manually convert that. That's big fun. Yeah. And I think, you try to change there's something, but it's true. That is the only test suite that we now have, and it requires a lot of. Most of them are really integration tests. They're not unit tests. They're just big. Okay, we encountered a bug. We dump the structure definition in, or the whole npm packages. We dump the instances in, and then see what happens. So that's the state of the art at the moment.
Yeah, that works if you have some kind of implementation which already working and you like working on details. But it's a very hard to start with this type of functional test.
Yes, I love that about it.
Almost impossible. Yeah. So.
And you had experience with this in schema. They did really in JSON schema.
Yeah, in JSON schema they do provide very like fine-grained unit tests. So you can like make this keyword work, then make another one, and yeah, so you're done. Yeah, so that's the idea. We do have a specification for that. So it's here, guys. Describe the algorithm. So it's a first draft, so our math guy tried to even write formulas. So, yeah.
Show off.
But yeah, I can show you how it may look.
Yeah.
So for example, using like US core. So we say that the base is patient. So we inherit from patient the URL for canonical, and then we just use required. This is from JSON schema. Yeah.
So you have the original canonical of the profile that led to this. That's still there, right?
Yeah.
That's the structure definition that you used to make this schema from. Okay. Yeah. That's the metadata. Okay.
So then we use very similar to JSON schema required rule to, because in FHIR now there's a strange combination of min and max. Which like resolved for like you define, is it array or not array, like collection or not collection, is it required or not required. So if we split this stuff and say like in JSON schema, is it required or not, it's much easier, and then min and max go let for the arrays.
But there was something in JSON schema, it's been ages since I worked with it, there was something weird going on there also with like open world assumptions, and you couldn't say these are the only things allowed. There was something like that in JSON schema, or am I wrong?
There like property pattern. There are some special cases, to do that, but.
So you basically list all the required fields.
Yeah.
Okay.
So we do have a maybe it's wrong. So maybe start from here. Yeah. So we introduce elements versus properties.
Okay.
So that's why? Because JSON schema property doesn't work, because we do have a primitive extensions, and they like just blow the JSON schema. So okay, let's keep this semantic, but introduce a new word, which is called elements with a FHIR semantic.
So elements represent the property and the underscore property at the same time.
Yeah.
Okay.
So that's what we can do. So, another stuff, we introduce types, and we do support FHIR types, not JSON schema types, but FHIR types. So you can put like human name, so looks natural. So another stuff, we do distinguish scalar and arrays. I understand there's still some amount of fonts of XML, but world is moving to JSON. So yeah, and in our code base, we want to distinguish like arrays and collections from scalar values. So it is nice if it's like explicit in a schema.
What is it? Scalar is true is the same as array is false, or am I?
Yeah.
Okay.
But I think guys did this because when you start profiling, so it's hard to understand, is it array or scalar, yeah? There are some corner cases, so, but it's discussable, yeah? So it's just the first draft we would love to discuss, yeah. So the cardinality is only work for arrays, for collections. So you can say min, max. So the choice types, yeah, they have 2 entry points.
Yeah, we did the choice types. I remember discussing that in Portugal with you, right?
Yeah.
The choice types. Oh, yeah.
They do have 2 entry points. So that may be too much technical details about this, but sometimes you entering choice types through the common prefix. Sometimes you entering choice types through the full element name. And so that's why they split into 2 elements. So you define the choice type with a prefix, common prefix, and you list what could be possible element names and JSON attribute names. But the most of constraints are put behind the qualified element names. So when you will merge schemas, so all the constraints will be merged in the right position. So yeah.
Yeah, and so in my stack, by the time we get to validation, I have only the name of the element. I not like the prefix, the postfix name anymore. So would there be a way for me to? Oh, that's the first one, multiple birth, and then I'll find the choices, and then I'll look up the choices in the schema. That's the idea. Okay.
Yeah, because for example, so we do use FHIR Schema to empower FHIR Pass engine to validate or for auto-completion. Yeah, in FHIR Pass, for example, you're saying yes, the value dot something.
Yeah.
So and here you enter through the common prefix. So if you
Yeah, there's a reason for that, and that's in the .NET stack. You can see that you're coming from the JSON side here, because in our validator, by the time we're validating, we have element names, and we have magically made disappear the JSON artifacts like something and underscore something. So for us, this is like, I can see why this works if you're coming straight from JSON. You're staying close to JSON schema. But I'd say this is a JSON artifact, but that's because I came in from the XML side.
This is a JSON artifact,
Yeah. I mean, so I figured, but correct me if I'm wrong, that they will both be there in the schema?
Yeah, they will be both. So, yeah, all of that, yeah.
Yeah,
because,
so that's to help me. So I come in from multiple birth, and then I can see, oh, there are 2 choices, and then I'll probably have to look up those choices in the same element.
Yeah.
I'm guessing, and then I can find that. Okay.
Yeah, but
but this is all like, this is just the stuff we made up, right?
Yeah.
And mostly you, actually.
Yeah, but again, this is a draft, so everything is discussable, and I welcome everybody to. And another feature that FHIR has is like excluded operation, yes, when you can prohibit some elements. So JSON schema doesn't have it, so we introduced like required and excluded. So you may just give a list elements which should not be present. So easy to implement. Yeah, easy to.
So excluded is the stuff that you said cardinality 0.
Yeah.
Okay.
So, but it is much more explicit. Yeah.
Everything that is not in the schema should be prohibited. So you should just take it out.
When you're doing profiles, so you do not apply this logic. So you're only profiling what you know. It doesn't mean that you prohibit the rest. So, but sometimes you want to, in your profile, you want to write that I don't need, like, let's say, observation value because everything go to component. So then you exclude the specific element or prohibit. I don't know, it may be a different word.
So if I try to validate with that JSON that has some random attribute in there, will it validate?
No, it will be validated with the keyword elements. But they will work, so again, so if we come to algorithm of validation, you are on a data element, and you keep in the context multiple schemas, and I call it like, so they do validation together. If one of schema recognize the element, then it's okay. If none of them, then you report error that nobody noticed. That's how like base resources can be composed with profiles.
And that is also different from JSON schema, right?
This is different from JSON schema, yeah.
Right, yeah.
And this is very specific for FHIR profiling, yeah.
Sorry, just as an aside, to make it more complicated, in the base spec, it specifically says that you should ignore unknown elements because you don't know if it came from a future version of FHIR. And so for validation, you can say it's kind of an error, kind of a warning. You know, there's this kind of gray area as we're getting into it. Yeah, and that's why it's one of those things that you have to play this line that the software engineer in me says, absolutely not. If it's unknown, it's invalid. But there has to be some wiggle room because if you want to be supporting normative additions, things like that, you have to have some facility for ignoring unknown elements.
Yeah, I've been conveniently ignoring, well, not completely that part of the spec, because for future compatibility, your client needs to accept stuff that it doesn't know, right? But it also means that if you're validating, you have to accept stuff that you don't know, which might be a misspelled thing. And it was, again, in Dallas, I think, that we said with Graham, and we're like, oh, so for R6, say if we're going to say that's all normative, and then from that moment on, we should accept stuff in our profiles that we don't recognize because they could be like from newer versions of FHIR, like, oh my gosh, never thought about that. So for now, it's a setting, actually, I think it's a setting in our FHIR client on whether we accept unknown fields, but our validator is still on your side, completely closed world. If I encounter anything that I don't know, it's an error.
So you can run it in this mode. So for example, so what we implemented, so every rule you can configure. And this is about the rule of elements. Yeah, so you may turn it into warnings, or you may ignore this type of errors. And another part about this, like it's a composability of profiles. Yes, so that's hard to do with a closed world assumption. Yeah. And I think this is a little bit unique for FHIR schema, that schemas are working together to, if at least one of them find the recognized element, it works.
Now it's getting back to me. This has been a big discussion in the JSON schema world on how this open world stuff and composable schemas and Well, if it was a problem, or at least a point of contention for them, it will probably become a point of contention for us as well.
What's interesting, for example, so Graham introduced these patterns, which essentially are interfaces.
Oh yeah.
So, and we're thinking in FHIR schema start supporting interfaces, so multiple inheritance.
Yeah.
Because there is no problem to not support it. Yeah. So in a FHIR structure definition, it's still like
Yeah, but these patterns are actually profiles that list a few elements, but not all of them. Right. So that's going to be okay.
And that's work very. So you don't you get it for free with the FHIR schema, like mix-ins or interfaces. So because again, the algorithm just expects that multiple schemas in a context, and one of them should recognize.
Now, one thing that I'd like to discuss with you, because last time we went over this, we discovered that our schema language and your schema language operated at a slightly different level of abstraction, and we got to that discussion when you showed. I think how you've encoded like slicing and reference validation here. Is that somewhere in this document?
It should be. So for references, it works like this. So I don't see it. Okay.
Oh, terminology binding, sure,
Yeah, yeah. So for reference, it looks like you see here, yeah? So we say type reference, and then we say refers. This is additional keyword.
It's an additional keyword,
Yeah,
and
yeah.
it might list one or more profiles
Yeah,
that the references
it could be
has to
multiple
align.
profiles, yeah. For
And
re-
if it's multiple types times multiple profiles, how did you do that?
what do you mean multiple?
Well, so you can a reference can be like multiple resource types, and then you can have multiple profiles. So you could do that either by like having if the reference is an organization, then these profiles apply, or if the reference is a patient, then these profiles apply, and so on.
Yeah, that probably we should work on a little bit.
Only one of them should apply. Yeah. It doesn't need to, exactly. So I think in our validator, you probably too, as soon as we find a match, I think we stop. But you might have to validate that all of them to see if not two match, but we stop as soon. So what we do, we look at the type, and then we take a subset of the reference profiles to make sure that we don't. So if you look at how this looks in our schema, and I'm not going to switch laptops because that would you have to use your imagination a little bit. We have refers to that first is a kind of a slice on the type of resource, and then each of these if statements, or let me say a case statement actually, because that's better. It's more like a case statement. So refers, and then we have cases for each type, right? And then each case statement is in itself a schema. And one of the things you could do with that schema is say, okay, I do a cardinal validation here, or I invoke. And in this case, the schema is, of course, one of the schemas that you refer to there. So when I compared your approach to mine, I was like, we did it a little bit more generic in the sense that a schema has like if statements, cases, any, all, and so on. And we have exploded, sort of we have expanded these specific things into lower level things. Now, I'm not saying that is better, by the way, because it makes it harder to have the correct error messages, because you've stepped down from, you don't know that you're validating references anymore. You're validating an any with a nested case statement. So to get the error messages right is way harder, although the language is more generic. So if in theory we'd invent new things or extensions or new structure, I could express it in the same language. But I must admit, when we discussed it in Portugal, I was maybe, and we've discussed it, Martin, in our API, and whether we should go like to higher level constructs instead of this like trying to make yet another Turing machine out of our schema language to write like Tetris or whatever.
That was our design choice, like to keep too close to FHIR as possible.
Too close to FHIR,
not to give like extra power to the users. Because if you're providing like case statements, so they could put case statement everywhere. So we do have, for example, like sugar for extensions. So the profile, so the slicing by extension is very simple. So yeah, it is convention that for extensions, this sugar work like this. But you don't write like slicing.
Yeah,
for
we would have a big, you know, well, we don't have slicing. We would have had the discriminator matching on a where statement or a case statement, and then you know more closer to the slicing. We turn the discriminators. Here the discriminator is the URL, and your code knows it.
It just
because
hard-coded,
it's an extension
because it's an extension.
But for a general slice, we figure out where it points to, and then turn that into case statements instead of a discriminator. How do you do that here?
The slicing operation, I probably will open it here. So let me see, slice. There's a special section for slicing.
And no discussion of schema is complete without a discussion of slicing. So.
So for us, the model of slices, you have a filters.
Yeah.
And you have a schemas. So the idea, you apply the filter to collection. If it match, then you run the schema.
Okay, so but you, for example, you here have a pattern. right? You have a pattern slide
Ewout.
here.
Yeah, yeah.
But how do you know against which element that is? Because the pattern might be, the discriminator might be against a very deep element, right? Yeah.
So question I have is that, because this issue currently we have with our FHIR server, that if you turn on validation, the performance really goes down, right? So from practical point of view, how will we use this approach with our FHIR server?
I disagree with the performance, so the validation could be fast. So you should not turn off the validation to get a fast FHIR server. Yeah, so the hope that if we would be able to standardize and simplify the validation, so the vendors will make efficient implementations of validators, so you don't have to turn it off. So, for example, yeah, we implemented this FHIR schema in our FHIR server. So, and to be honest, it's 100 times faster than Java validator.
Yeah, but my question is...
But not because of the schema, yeah, because of other tricks, but yeah.
But I'm just saying that somewhere, I'm not sure when our vendor will implement it, but if you want to take it on, do you have some approach that if we can use this approach ourselves and maybe add it to capability to our FHIR server?
Yeah, so I hope there will be a lot of implementation of FHIR
That's the whole
schemas in
point.
different languages, like let's say Golang, Python, JavaScript, and if you pick like open source or closed server, or if you're gonna implement this server, so you're just taking standard library for that. So that's where I started. This is a pain point. We only have Java and C# reference implementation. We don't have for other technologies.
Okay.
For many years. So if we will have more, but yeah, the problem that it's hard to implement. So if we lower the border of implementation, we will get a lot of libraries in all the possible languages. I don't know, Rust, Zeek.
Now I'd like to have
this will
in
simplify.
30 seconds I'll have one more answer. And that is what we've tried to do. I think validation is expensive, by the way. You can't make that go away. I mean, just parsing it and dropping in your database is always going to be faster than validation, especially if there's terminology services. We didn't even talk about terminology. But anyway, so what we are also trying to do is doing one thing we could do is doing the simple things first. Like, don't start validating terminology if the basic stuff is not correct, because you could report that, and only if that's correct, you could go deeper and do terminology. I had deep discussions with, well, basically with you here, with a few of the guys on this table, about can you do this progressively, so you know that all this stuff is already valid against the base profile. Now we have to check this against sub-profiles and so on. Okay, we're at time.
Yeah.
All of this was just to introduce you to the fact that this is going on now, and that we both are very enthusiastic about this. Both stacks currently have implemented it completely differently, as I've been, I know we try to explain. And this is a thing that that we want to work on, over the next years, I guess. So join us. How shall we put the link in Huva, or?
Yeah, we will post the link in Huva. So we do have a channel in Zulip. We do have a repo, which is not yet part of the FHIR Foundation, but I hope it will become soon. So yeah, so if you want to join JavaScript implementation, so I just working on it right now. So
or if you want to make a Haskell implementation.
Yeah.
Sure.
So yeah, there is an open validator which run our implementation of FHIR Schema. So as well, it works with a mirror of all official packages in the FHIR Schema format. So we already converted most of popular schemas into FHIR schemas.
Dot.
Yeah.
That's the end of it, my friend.
Yeah. Okay.
All right.
So I'm stopping here. Too close.
Thank you.
And maybe important part there, yeah, we're gonna make working group meetings. So if you want to participate, yeah, please contact me or Ewout. Yeah. Thank you.